Well, while it seems simple enough, this was a real pain in the butt to get that in there. And make sure that all of the little cross pieces are in the right angle. So this has an elbowy look to it, right? Make sure it's an elbow and not a knee. Um, could be this way instead of this way. Right? Same way on the other side. Make sure that both of those were right. Make sure that the valve rod at the top and the cylinder rod at the bottom, right? Both are inserted. Make sure that the slider is on the rails on both sides. Now all I have to do, he says, all I have to do is right here the slider to the drive rod. Hopefully I can get that accomplished and be right back. Alrighty then, I just laid in some double-sided sticky tape and finished this side up, and we need to lubricate it a little bit. So let's make sure that everything is lubed before we even try to run this. We're going to use a fine motor. This is a motor lube by my friends at Aerocar, and you can buy this at the Train Buddy shop. I buy this stuff fairly regularly and love it. That's about the only thing that we use here at the shop. And we talked about this before, but this is Aerocar motor lube, and we're going to use this on the outside, and we're going to use it at every joint where, again, that's movable, that's not electrically conductive. It needs to be conductive. So these are non-conductive joints that we're lubricating. And again, if you were in the real world and in a prototype environment, you would be lubricating all of these points. The old pictures that show the engineer out with the big oil can, this is what they did on a regular basis. And if you have these kinds of engines, you should be doing this on a regular basis. These points are wear points, and they will wear. We can also put it on the sliders here, the cylinders, that rods, and the valve rods. I'll go through this again. I don't know how much of this you can see. I'm getting out of my chair and losing my spot here, but all of these spots that are moving joints, you want to make sure that they're lubed. And I'm putting a drop on there with this. This is a very very nice point on this with this metal nozzle. And again, this is an add-on. You can buy these separate from Aerocar, from the Train Buddy, but making sure that all of these points are lubricated. Now inside on the motor, we want to make sure that the bearings, these bearings, are well lubricated. These are sleeve bearings. Again, they don't spend a lot of money putting ball bearings in there. These are tiny bearings. They're sleeve bearings, and because they're sleeve bearings, they also require lubrication on a fairly regular basis. Make sure that you're lubing the gearbox on the side. Here is a little is the axle for the gear, main gear, right on both sides here. Make sure you get that one done. Now, here's the tricky part, which is the wheels themselves. The wheels are conductive, so we're going to use a conductive, and they conduct electricity up through the rail. So we're going to use a conductive lube, conduct the lube, right? Again, by our friends at Aerocar. And we're just going to add a conductive lube on the axles here, on the axle points, right? because it conducts electricity. We're also going to put it inside here in the gearbox only because we've got it out and we're there. We could have used the other lube, but again, not really necessary here. The wheels are kind of brass, and they're kind of, I don't know if you can see this or not, but they're kind of pitted in spots. We're going to clean those up as best we can, but again, because this is a brass engine, older brass engine, these wheels and the wheel sets would need to be cleaned on a very regular basis. All right, we're ready for test. The engine is in there fairly well. I put double-sided Scotch tape, 3M tape. I buy these in huge rolls and use these quite frequently to temporarily, if nothing else. We're going to go ahead and see if that stays in there. If it does, we'll leave it. But if we wanted a permanent or a more permanent, we would use a RTV, which is room temperature vulcanizing, and which we've used before. This is Permatex Clear RTV silicone adhesive sealant 66B. You can buy that in an auto parts store. It's not something that I stock just because I don't use enough of it to worry about. I go to the auto parts store to buy it. We're going to go ahead and power this up and be right back. Okay then, so we've powered it up, and it seems to be running fairly well. The cylinder that we fixed looks good on both sides. Let's see what the other side looks like. Oh yeah, looking good. All right. As we look at the meter now, we find out that we're running at 12 volts, but we're only running at 80 milliamps, which is like, wow. This is almost an issue. We're going to go ahead and I'm going to see if I can get both of these things in the picture here, and we're going to go ahead and turn down the voltage. Matter of fact, I'm going to move the whole engine over here where we can get a better look at it. 8, 6, 5. Notice it stops at like 5 volts, right? And it's kind of, this thing should actually run all the way down to like a couple of volts. The motor itself will run at a couple of volts. The issue here, I think, is the lubrication, possibly. It looks like the mechanism itself is lumbering a little bit. By that I mean it's moving side to side. It's hard to see here, but if I put it here as a reference, right, you can kind of see. Oh, here you can see it on the pilot. Watch the pilot move back and forth. Right? So it's not too bad. Actually, we would expect it to do a little bit more of that if the wheels were not exactly 90 degrees opposite each other. So I don't know if you knew this or not, but it's called quartering, right? Quartering is when the wheels are cylinders are exactly 90 degrees out of each other from side to side. Looks like we have a lot of gunk and buildup right here on the gearbox. May be worth an effort to strip down the gearbox and clean it up. I think that's the next step here. But it looks good. It looks like we've got the red and black on the right side too for it to go forward. And we'll be able to mark those. But I feel good about this. I'm going to start. It may even be, now down to 4 volts. Yeah, it just may need some run-in. We're going to go ahead and grease up. We're going to use some grease. Again, Aerocar grease, special stuff that until I've had this around for a while. Gear lubricant from Aerocar. And we're going to go ahead and put that on on the cylinder slide rods, and hopefully that'll improve things. And we're going to tear down this this gearbox and see what we got there. Be back in a little bit. All right, so we got it apart, and we noticed that the gears were not lubed at all. So we put some gear grease in there, and now I'm about to put the cover back on. So there's a little bit of a secret here on how to do this. These are brass screws, and they're really small. So here's a brass screw, and it's really small. And I don't know if you can see this or not, but we put a goop on the end, put something to hold it on the end of the screwdriver, and that facilitates us putting this into this. It's about ready to fall off here. The goop that we're talking about, and I always keep it close at hand, right? Is this? It's an adhesive that's stretchable and gooey. It does some cleaning too if you were going to clean some stuff up. I keep a blob of it here by the workbench. It comes in a. I just put it up here. What did I do? Here's an example of this kind of stuff. It's called adhesive putty. Let me zoom out a little bit. Adhesive putty, removable adhesive putty by 3M and Scotch. And I'm sure you can find this just about anywhere at just about any store that's got. Well, in this particular case, it was somebody who was like Michael's or a craft store that. What do they call those books? Scrapbooks. People that do scrapbooking. All right, so I'm going to attempt to put these screws in here so you can watch a little bit while I do it. Again, a little bit tough to do this. So we put that adhesive stuff on the end of the screw so we can put it in there. So I'll try to keep it still while I do this. I'm going to add a little bit more of the adhesive. And again, if you were to try to do this with tweezers and just manipulating it by hand, it would almost be impossible. But using this adhesive stuff with this just makes it just so much easier. And I'm going to hold I got to hold the gearbox from the upside also. This is harder when there's no engine in it. With the engine in it, kind of holds the gearbox steady while you apply the screws. So once you get the first one in, the rest of it's pretty easy to do. I'll just go ahead and finish it up. And again, using the adhesive putty, right, make sure that I got the screwdriver in the slot. Right. Works like if you've seen the magnetic screwdrivers, but of course this is not magnetic, it's brass. They're brass screws. Got to line the hole up with the threads. So let's do that. Hopefully my hair is not in the way here. Just use some kind of a mechanism to do that. And actually, you could use the screwdriver itself to kind of line it up. And again, put the screwdriver. You see, this takes a lot of time to do these kind of things and do them right. And again, a lot of guys wouldn't have even bothered with this. It's one of those things that just makes the job that much better, and also ensures that it's not coming back. I hate engines that come back. Not that I hate them, it's just I try not to have them come back. And also you expect, people expect you to do not just a good job, but a train buddy job, which is an expert job. So you get a feeling now for what that's like. or what quality I expect. All right, trying to get that in that hole. Come on, come on. I know you can't see this, covering everything over with my hands. There we go. And ta-da, done. All right, now we're going to go ahead and run it again. So let me set up to run it. I'm taking the adhesive off. I'll put it back in my pile. Okay. Run it again, and let's see if that didn't improve the run characteristics. Okay, we're still a little bit rough. The voltage again at 7.5. And try to get it all in the same shot here. Voltage at 7.5 and 60 milliamps. 0.06 amps is 60 milliamps. Okay. Now we're going to go ahead and bring it down. 5 volts, 4.8, 4.6, and it stops at 4 volts. I don't know if that's any better or not. It needs a pulse to get it started. I'm fairly satisfied with this. The motor again is one that I expect it might even bog down when we load it up. It could have been a motor that had more amperage, would have given it a better pull characteristics. You see the bearings are starting to look cleaner. I don't know if you see this bearing right here, and how much cleaner it looks now that it's been lubricated. The whole system is better at higher voltages. When we go up to 12 volts, which is what it's, most of these motors are designed for. 70 milliamps instead of 80 milliamps, so we're getting better. I suspect the more that this runs, the better it's going to get. It seems to be running very, very smoothly at this point. Again, we got a little wiggle on the front there. That has a lot to do with things like the wheels and cleaning and Lord knows what all else. But I'm very happy with this. This seems to be running very, very well. So it's time to put a decoder in it. Might want to put the shell on and try this again, but we need to run some wires too. So, all right. All right, so one of the frustrating things with these engines and with a lot of things is, I cleaned it up. All right, so in the process of cleaning it up, or maybe it was that way and I just didn't notice it, the drive shaft or the piston shaft came out of the crosshead again. So I'm going to have to take it off and I'm going to have to redo it. But in the process, I noticed if I turn this by hand, like this, right, when it gets close to the piston head right here, it seems to be going pretty nice by hand. But when it gets right there, it gets really hard, and it's pushing up against the piston head. So again, trying to put it back into place may fix that, but this is like unforgiving hard, and me even turning it by hand, I really can't do it. What I'm thinking is that this needs some adjustment. These are all handmade engines. The brass engines are. And this is no exception here. This is a casting, And oftentimes you have to make some minor modifications. And in this particular case, what I'm going to plan to do is at the place where the cylinder, where the shaft meets the cylinder head right here, I'm going to go ahead and shave that down by taking a little file. I'm going to take the piston rod out, and I'm going to take a file, and I'm going to file this back in this direction, so that it gives a little bit more room. There you can see there's a little nib at the end of the shaft, right where it goes in, and that may be enough. I mean, we're talking thousandths here, but thousandths oftentimes makes the difference between an engine that runs well and one that doesn't run well. See if that doesn't make a difference. Again, I'm not real happy with the performance characteristics of this motor, this motor and this engine, and I'm not about to just throw some wires on it and do some DCC on it until we make sure that this is working at its peak performance. So, be right back. Okay, so while I'm waiting for for this to cool, I thought I'd clean up some of the engine and whatnot, and so I decided to use, and I have been using this as a cleanup product. It's Dust Dauber by Woodland Scenics, and of course we have it at the Train Buddy shop. It's supposed to be, and they designed it specifically for removing dust. It says without scratching, and they show it in use with ponds and that kind of thing. Water is typically an issue, but I find it's very useful for things like this, where you've got a piece of rolling stock and it's got little nooks and crannies and in areas that you really couldn't get to. I mean, I could brush this stuff. You could wash it in the sink if you want, but again, this is a delicate model, and so you really don't want to disturb things like that. So just using this dust dauber cleans it right up, and I just wanted to show that I was doing that as a part of this fix-up. Again, it gives a better appearance. It's kind of like having your car washed when you get maintenance done. This is pretty much the same thing, except we're charging a lot more money for doing an install here. But just to show you the difference between what it was and what it is now, it makes a big difference. Okay, so I did several things, one of which is I reamed out the cylinder, specifically where the rod goes into the cylinder right here. I reamed that out on both sides to give it a little bit more clearance, and as you can see, they're both working pretty well at this point. I'm going to cut back the voltage, and again, don't know how to do this without screwing it up here, but cutting back the voltage from 12 volts down to 5. Remember before it stopped at 5, now it's 3.6, 3.5. Notice it's 30 milliamps, right? Oh, this is good. We're at 2.5 volts. And the motor is still running at 2.5 volts and 30 milliamps, and it stopped at about 2 volts. So, I mean, I am super happy with this, and I'm gonna bring it up now and see when it actually starts. Looks like the motor starts to turn at 2 volts, 2.5 volts, and 0.03 or 30 milliamps, and even at, I don't know if you remember, or you just look back in the video, but at 12 volts we were running somewhere in the neighborhood of 80 milliamps, and then I got it down to 70. Look at it now, it's only 50 milliamps. So we've taken a lot of the drag, mechanical drag, out of it by doing that. And to be honest, I probably could take some more out of it if I go back down here and look at where the binds are. It's now binding on the other side. It's binding on this side, and I take it apart again, but I'm not going to. I mean, it's such a hassle to get it back together again. Take it back from that side and go ahead and right there it's binding, right, and I can feel it in my hand, right, and just a tad, just a slight tad, and if I was going to fix it, if I was even going to attempt to fix it, I would shave off the little collar that's right there. Just thousandths, half a thousandths maybe would make this even better than it is now, which is absolutely fantastic in comparison with other ones. So just to let you know where the progress is at this point. Haven't even started doing decoding yet.